Hello, and welcome back to Schneider Electric's Healthcare Innovation Talk series. My name is Briley Shaw, and on behalf of Schneider Electric's global healthcare segment community, I'm delighted to have you here with me today. The global healthcare sector is in a period of profound transformation. Powerful forces are pushing the boundaries of what's possible, redefining how healthcare is delivered, enabling breathtaking innovation, leading to better outcomes for patients, providers, and facility leaders alike. It's an incredibly exciting yet challenging time to be in healthcare. This Innovation Talk series is our response to that reality. It's an opportunity to explore the evolving healthcare landscape with particular focus on digitalization and electrification. At Schneider Electric, we harness the power of these twin forces to design and deliver digital solutions that are ready for today and flexible for tomorrow. Our first Innovation Talk centered on the transformative power of digitalization. Today, we shift our focus to electrification, a vital strategy in which healthcare organizations replace fossil fuel-based technologies with electrified alternatives to create the next leap forward in efficiency, cost savings, sustainability, and resilience. Today, we're excited to bring together healthcare leaders and solution experts at the forefront of implementing these strategies. Our guest speakers will share firsthand experiences, lessons learned, and insights into how electrification enables operational excellence without compromising regulatory compliance or patient outcomes. Finally, today's Innovation Talk will close with the formal release of our brand new white paper, The Rise of the All-Electric Hospital. This white paper expands on the topic of electrification and includes a case study analyzing the impact of electrifying an 800-bed acute care hospital. As an attendee, you'll automatically receive a copy of the white paper following this event. Before I turn you over to the next segment, please remember that this Innovation Talk is interactive. We've got experts on standby and ready to engage with you in the chat. Please post your questions and comments to get a response in real time. And with that, it's my pleasure to pass you over to David Evans, Global Healthcare Segment Leader at Schneider Electric, for our first panel session of the day. David, over to you.
Thanks, Briley. Welcome, everybody. Good morning, good afternoon, good evening, wherever you are in the world. Thanks so much for joining. So I'm David Evans. I'm the Global Segment Director for Healthcare for Schneider Electric, which means I get to work with healthcare providers in different parts of the world. And very much that work is around the electrification, digitization, and decarbonization of healthcare estates. But today we're not here to listen to me talk. We have three esteemed panelists who live and breathe the reality of making this happen in healthcare estates every day. And today's very much about them sharing their insights. I'm super grateful for their time, and I'll now ask them to introduce themselves.
Yes, certainly. So I'm David Jones. I am the Director of Estates, Facilities and Capital Development down at University Hospital of Southampton.
And Jason?
Jason Light, and I'm the Head of Sustainability and Energy at University Hospital in Southampton. So I work within David's team.
Marvellous. Tony?
Yeah, my name's Tony Goddard. I work for NHS Wales Shared Services. I'm the Principal Electrical Engineer, also dealing with all things electrical within NHS Wales, and the Authorising Engineer for HV Systems.
And guys, thank you so much for joining us. I know you're super busy people, but this session is very much about practical insight into the problems we face. I'm going to prompt some questions, but feel free to expand and really share your experiences. So I'm going to start with David, if I may. As you know, we've done lots of modelling, systems modelling around what an all-electrical state would look like. And roughly speaking, we know that it's going to draw about 2.5 times more power than a traditional estate with a fossil fuel mix, something like that. So my first question is there really enough power in the grid to do this? And please share your experiences in Southampton.
Yeah, certainly. So simply the answer is no. There is not enough power and supply in the grid at this moment in time. And I know there is the big upgrade going on across England and across the networks and the power companies. However, we are finding already that there are significant barriers to not only healthcare, but wider infrastructure issues across the whole of Southampton. So we've been doing a work with a group called the Renaissance Board, which is the main key employers and businesses across Southampton, really mapping out the next 10 to 15 years of how much energy we need to grow our businesses, to keep relevant to the community of Southampton and wider. And one of the things we've found is in the next 2 to 3 years, we are going to start running into problems around how we get electricity to where we need it to, so we can continue not only on upgrading our systems, but doing so in an environmentally sustainable manner. We're having that issue within University Hospital Southampton specifically, because we have a master plan to add another 40 to 50,000 square metres of infrastructure onto our estate, which significantly increases, almost doubles our requirement over the next 10 years. And our provider at the moment does not have the same roadmap we do. So it's working with those providers to understand our roadmap, and likewise for us to do theirs as well.
Tony, can I ask the same question to you and reflect on your experience in Wales?
From a Wales perspective, we do have similar issues to other NHS organisations with England. We have a few new builds on the go which are all electric, and we are talking significant amounts of power, sort of in the region of 6 to 9 megawatts at the moment. Our initial experience with the distribution company is that they can provide that level of power to the building, so we're okay with that. I think our real issue is when it comes to decarbonisation of the existing estates. I mean, typically we're looking at an estate in North Wales where it runs at 3 megawatts. To meet its current growth, which is natural growth, and to build 2 new buildings which are required, they just have to double the maximum demand from 3.3 megawatts to 6.6. Then if we talk about decarbonisation, we're talking 10 to 13. So to get that 6 megawatts, it's going to take us about 2 years to procure that for the distribution companies to do their upgrades and reinforcements. But then to try and get to 10 to 13, we're talking anywhere between 5 to 7 years to achieve that. Now, that means coming across highways, people's land, so there's a lot of legal frameworks to sort of get in place to get over that. I think the thing we see that as achievable, but it depends on the region you are. We think in South Wales, one of the areas we got in one of our own facilities, we need to increase our power, and at the moment we're sort of hamstrung because we're told the power is not there. But then by the same breath, we've got an independent distribution company saying we'll build a 300 megawatt primary substation to serve a data center, another provider and ourselves. And he said, yeah, no problem, we'll pay for that. But then it begs the question, is there 300 megawatts in the network to give us that? And to that answer, they haven't given us an informed question on that. I mean, my gut feeling is, when I've dealt with cities like Cardiff and Newport, you can, quite easily get 1, maybe 2 megawatt increase. But when you're talking significant, over 10 megawatts, it's a big ask. We've sat on the forums with Transport for Wales, Scottish Power and National Grid to talk about, electric vehicle charging, and we always come back to the same thing. Until the network infrastructure is reinforced, expanded, it's pointless installing it, because if you can't feed it with the capacity, then that's your limiting factor. So, much the same process, but I think that's the sort of investment which NHS, healthcare organisations, they can't put that money into the infrastructure. It has to come from central government, really. They have to put that infrastructure in to allow organisations to grow.
And without it, we're engineering a single point of failure into our master planning. But I need to park there because I could talk about that all day.
Yes.
I'm just going to throw one sort of slight curveball question, and back to you, David, if I can. Is there a role for hydrogen in your master planning for the future of, say, do you think the healthcare of the future really could squeeze hydrogen into the mix?
So from my perspective, I really hope that hydrogen companies and the government start to develop the network for hydrogen. We can create as much hydrogen as we need, as I've been advised. The problem is get it from A to B. And yes, it is clean energy. It is relatively simple to produce, relatively, I hasten to add, but it is the transportation and storage that is the real issue that we're having. I think if we put all our eggs in one basket on electricity, we're going to have a problem down the line. There's only so much wind and solar that you're going to be able to produce. So how else are we going to be producing electricity going forward? Things like putting solar on every single new, mandating solar on every single new house, every single new development is for me a no-brainer, but we're nowhere near there yet. So how do we at UHS, where we are going down that, if we've got a spare bit of roof, put a bit of solar on it, type approach. We can't really do wind. We are doing geothermal, etc. But there's still going to be a huge gap in 5-7 years' time when we turn off our CHPs. How are we going to bridge that gap? And at the moment, we're looking at a hydrogen network that is going to be nowhere where we need it to be in that 5 to 7 years' time. But there is a definite need for it.
And again, we'll take that as a discussion for another innovation talk in the future. But you raise an interesting point there, and I'll go to Jason if I can. Could you just share with us your experience of trying to integrate renewable storage, geothermal onto your estate? And two things. One is the logistics of, how do you go about it and every bit of spare space? But secondly, how do you get people to pay for it? In a cash-strapped NHS, how do we get people to invest in green energy?
So I've been involved in this from development of housing estates and all sorts in my career, and certainly for a large acute like we are in the NHS, renewables is the business case is fantastic because we will use 100% of that electricity because of the sort of amount of space we have and the size of the hospital. There is no need for storage because it will be used.
You just use it on the spot.
So the business case is quite good, but you're still competing with the capital program with that. We've been doing it predominantly where we need to with the sort of planning and the requirements under the greener NHS and the building standards require it, but also where possible with grant funding. So we're currently delivering a Salix program through 3B, which is giving us a large solar around one of our car parks. So it's not blocking any other infrastructure, but it fits in with that program.
Excellent. Okay, I've got a nagging doubt in my head around electrification, because when we talk about fully electrified estates in a grid-constrained environment, these are complex estates. We're going to have smart switching, SCADA systems, load shedding, really sophisticated electrical networks. And I'm going to ask Tony the question. I can see how we can design them, pretty easy. They look great on paper. How have we got the expertise in the facility staff in our sector to maintain, to manage and optimize this type of estate?
I think in the present situation, there probably isn't the skill set to enable systems like that to be kept in full working order. I think typically with the estates teams, they would bring in the specialist teams from whether it's the manufacturers or specialist contractors to do that maintenance work. It's not to say that they can't do it, but like everything else, if they need to do it, then they would need the appropriate training and skills. But I think one of the issues we've got with estate staff, whilst you can train them, they've probably got so many other, issues and, work that needs to be done. They probably haven't got the time and resource to be able to take on another task. So I suspect, any of these advanced, technologies which are, are going to come on stream, it'll probably mean more work will be outsourced in terms of maintenance.
And same question to you, David, if I can. Just your experience of recruiting and retaining facility staff.
Yeah, so don't disagree with what has just been said. I think for me, though, we need to step up to the challenge. So we already have a challenge within the NHS recruiting and retaining estate staff, engineering staff, good quality engineering staff that then stay within the NHS. I have no problem at all in training and developing my team that I get. It's getting them in the first place, getting them through the apprenticeship route and really developing them the NHS ways. But you're absolutely right. With these new technologies, we are going to have to not just be training our apprentices on how to implement those new switches and the new systems and how to maintain solar, etc. But for me, it's very much about a mindset of our senior engineers from what they know of traditional engineering to a new modern technology of engineering, and not be afraid of it, if you like, and to understand actually how it's going to benefit them in the long run, how they're going to be able to manage and maintain all of the estate much easier than having to go around every single switch manually and see what it's doing. So there's a huge development program, and for me, I'll be looking to NHS England, I'll be looking to the colleges, university, as to how we step up with that program and how we support those, because it's great having somebody like Jason at the university hospital really going out, getting the money, putting in new systems, but then we're going to manage it. And I really don't want to outsource all of my estate when we can actually be developing those systems and services in-house and working with partners such as Schneider.
That would be wonderful.
I would say I've been working on sort of demand side and dynamic management of electricity systems for a while, and I actually think it's a cultural shift. You can sort of train engineers to understand new technology, and they're fantastic at that. But when you're talking about that kind of technology, you're talking about a technical fix to a problem that from an engineer is normally a physical fix. You know, you only will allow X amount of infrastructure in based on the available capacity. Whereas what you're saying is we're going to move that utilization around or hold off using something. And I don't think people appreciate how big a shift that is. That you've had decades of people learning that you can't plug that in because there isn't enough power. But the actual question is, do we need to use that power now? And the technology is there to restrict it and hold it. But that's a very different mindset. So I actually think there's cultural there that needs to be kind of driven through some of the institutions, as well as David said, some of the education establishments.
It's a really fascinating point. I mean, it's a strange thing to say as a technologist, but in reality, the technology is the easy bit. It's the organizational change and that cultural stuff to adopt that technology with the skill sets in the right age group that we need to adopt. Guys, I could talk to you about this stuff all day, but I'm being heckled from the bleachers on timing. I think we've got a lot to learn from each other. And on that, David, I know you're doing a PhD in related subject. I wonder if you could just ask for some help in support.
Absolutely. So my PhD is looking at the impact of infrastructure failure on patient harm within the NHS. And please feel free to visit my website. I believe we'll be putting the link in the details. And contact me directly through the website or LinkedIn if you've got any questions on it. But any viewpoints on how I can take that research forward, I welcome any comments.
Gentlemen, thanks so much for your time and your insights. It's been absolutely fascinating, but now I must hand back to Briley.
Thank you, David. As our panelists pointed out, electrification is quickly becoming a strategic imperative for healthcare facilities across the globe. Achieving success requires more than transforming infrastructure. It's about collaboration, education, and commitment to a new way of working. In our next segment, Dan Garcia, Global Healthcare Segment Solutions Leader at Schneider Electric, will address the challenges, opportunities, and technical implications of electrifying a healthcare estate, calling on the case study in our white paper, The Rise of the All-Electric Hospital, to demonstrate the point. Dan, the floor is yours.
Thank you very much, Briley. Welcome everyone to the more technical session of this event. My name is Daniel Garcia, and I'm the Healthcare Solution Team Leader at Schneider Electric. This session will dive into the challenges, opportunities, and technical details of electrification by discussing a real-life case study that demonstrates the process of electrification on a traditional hospital design, currently in operation. To do so, we will quickly overview the specific technologies, implications, and outcomes of key electrification scopes, such as the electrification of heating plants, the implementation of distributed energy resources, as well as other technologies to reduce the hospital's overall power demand from the grid. This case study serves as evidence of how electrification is the key driver of decarbonization in healthcare estates to drive sustainable development, improve energy security, and create new economic opportunities. By sharing our experiences and lessons learned, we hope to inspire others to embark on similar journeys and contribute to a more electrified and sustainable future. Our case study is an acute care hospital located in a Mediterranean climate zone and counts with almost 800 inpatient beds as well as outpatient consults, providing general medicine, surgical, critical care, allied health, and other medical services to almost 500,000 patients a year. The electrification scope we have tackled in this white paper covers all typical fossil fuel systems in a traditional hospital design, including heating hot water and domestic hot water plants, kitchen and laundry services, fleet vehicles, emergency response vehicles, as well as emergency backup power. Additionally, we have included in this study an analysis of the role of microgrids, renewable energy sources, battery storage systems, as well as electric vehicles, as all of these technologies will be key in the all-electric hospital infrastructure. We are not going to go through all the exact calculations involved in the electrification in this session, but all the detailed calculations can be found in our white paper. The findings of this study reveal a significant increase in power demand from the grid, estimated at 2 to 2.25 times the traditional designs one, obviously for our climate zone. This factor could increase significantly in colder climate zones, potentially climb it to 3, 4, or even more times the original power capacity, depending on the current cooling requirements in summer, as well as the current heating procurement model, with significant differences between on-site heating and district heating. Most of this increase in power capacity from the grid comes from both the electrification of the heating and hot water plants, replacing gas-fired boilers with air-to-water and water-to-water heat pumps, and the electric vehicle charges required to electrify both hospital-owned fleet vehicles and emergency response vehicles. One of the most significant consequences of electrification is the stretch on the grid capacity, potentially challenging its ability to reliably deliver power to all customers. To overcome this, it is imperative that hospital facilities invest in on-site energy production and storage technology, green emergency backup power systems, such as hydrogen plants, as well as microgrids to proactively manage loads depending on measured and predicted demand. All these technologies and their role in the all-electric hospital are discussed in detail in the white paper. To discuss more in detail some of these technologies, I'm honored to have with me Mr. Derek Smith from our Electrical Design Digitalization team, ETAP, and Mr. Kevin Jones, Consultancy Director in UK&I, who will help us understand the implications of electrification as well as the overall role of electrification within a wider decarbonization strategy. Well, thank you both for joining me today. So let's kick it off with you, Derek. Talking about electrification tools and technologies, which do you think is going to be the role of microgrid, distributed energy resources, and digitalization tools such as digital twins for the electrification of healthcare facilities?
Okay, yeah, I think digitalization is transforming the way that energy systems are managed, are optimized, especially when we're looking at healthcare. I think the old way of just having a system, adding on a circuit without doing any simulation, without understanding the demand of the network and the impact to that network, those days are gone now. We need to be more efficient on how we manage our networks. And the digital twins are used in many ways. The digital twins are used as a graphical representation of the living and breathing network as it is today. Also being able to manage and track all of the changes within the network is also important, and that's the role of the digital twin. We also look at digital twins for predictive simulation. So when we are upgrading our networks, how do we know that that change is efficient, is safe for the network, is resilient, and it's not going to have a negative impact to the network. So using digital twins to carry out predictive simulation, to run the different scenarios, is absolutely the way forward. The other thing with doing pre-simulations for the digital twins means that you are reducing energy on the network and you're improving the efficiency, thus reducing costs.
Yeah, that's fantastic. I mean, it looks like digital twins can help us understand what is going to be the capacity stretch, maybe, on the grids. We've identified that as a problem when we talk about the electrification of heating plants, for example. So could we use the digital twins maybe to simulate different scenarios and understand how it's going to impact on maybe transformer capacity and maybe draft different pathways to electrification? You think that's a path to go?
Absolutely. And I think being able to carry out different scenarios allows you to look at peak shavings for the network. So what's at different times of the day, how do I make my network more efficient? And running those simulations and those scenarios allows you to predict the entire demand for a 24-hour, 7 days duration of the network.
Yeah, no, that's fantastic. It looks like digital twins are going to then become the cornerstone for design on electrification. Okay, so Kevin, we're talking about electrification. We know electrification is just one component on decarbonization strategies. It's just not the decarbonization strategy only cornerstone. So based on your experience working with customers on site, could you give us maybe some steps on this, some maybe pathways they take in steps on electrification, but as part of the sustainability strategy? What are the key steps they take in realistically these days in terms of electrification?
Okay, so you'll find most healthcare estates are many years old and they evolve, they're constantly evolving. So you find equipment that's 35 years old, 40 years old. The first step is to understand what you have. You need to know where you are at on your journey. So the first step is to really do a deep dive audit of all of the infrastructure on site, understand the ratings, the age, the equipment, the profiles, to really understand, because there's no point you trying to decarbonise on a network that won't cope with that decarbonisation. Then you need to think about, okay, I need to then model that in a mathematical space. So that's where I'm using the digital twin, I'm using the tools that are available to build proper power system models. Once I've built that power system, then I can determine, okay, where is my decarbonisation strategy? What is it? Am I looking for electrification of my fleet, ambulances, mutes, low lorry transports bringing equipment in, car park EV charging for staff and for the patients, as well as electrification of the boilers, air source heat pumps. These are all the new buzzwords in decarbonisation. So what you've got to do is, once you've built the model, you've got to add those on to the circuits to run your simulations. Now, you may find, as many customers do, there's not enough capacity, so you need to increase your grid capacity coming in. Doing that has lots more challenges because your network's getting more complicated. The equipment sizing is physically getting bigger. The use of the electricity is greater. So therefore it becomes a greater risk in terms of safety and security. So then you have to think about, how am I going to mitigate those things? How am I going to calculate my short circuit levels? How am I going to make sure that when I'm interfacing with the electrical system, which is critical for any healthcare environment, I have the right tools in place to understand the risks I might be facing?
Yeah, no, that's fantastic. Actually, that brings up a question about documentation. So how frequently do you find documentation available when we're talking about electrical infrastructure, SLDs, etc.? Is that a challenge when we're talking about electrification?
So I do a lot of auditing. And in the 30 odd years with Schneider, I've done a lot of auditing on sites. And most cases, the single line diagram is always out of date. Sometimes it's 5 years out of date. Sometimes it's in the substation when the substation was built 15 years ago. So that actually answers a couple of challenges. First of all, technically, you need to have an up-to-date single line diagram. It's in the health and safety guidelines for this country, particularly for medium voltage power systems. You have to have an up-to-date single line diagram. But then as your network is evolving, you need to understand where the circuits are, how they're being isolated, what protection requirements are, what the load currents are. So you need to start, once you've, I guess, built a digital twin, then keep it up to date. That's the key to all of this. Don't do it once. Don't do it every 5 years because a piece of legislation might say to do it. Do it every day. It becomes an integral part of the management tools of your healthcare establishment, that digital twin.
Yeah, that's fantastic. I think that's going to help the electrification scopes because we're going to have a live documentation. Okay, so rolling back to electrification and rolling back about a topic that I particularly like. So when we talk about electrification, we rarely speak about emergency backup. So what are your thoughts on the new technologies, greener technologies for emergency backup? Do you think they are up to speed with traditional gensets, and do you think they would play a wider role in the strategy of electricity procurement?
I think what we need to be doing is rather than having expensive equipment on standby as backup generation in the event of failures, with the evolving technology that we have in renewable sources, I think when we're looking at solar panels, we're looking at wind turbine generators, we're looking at battery energy storage. I think now is the time that we need to be integrating these technologies into the day-to-day use of the network. So rather than having expensive tools on standby, we are reducing the risk of the assets and the demand of the assets on the network by utilizing the renewables. We're also then reducing our carbon footprint, because when we're looking at decarbonization, we have to be able to understand the carbon footprint for every single component on the network. And this is where we look at the integrity testing and the resilience of the assets on the network.
And just to add to that point, I think, Derek's talked about generation, DERs, distributed energy resources on the networks. I can see in 10 or 15 years' time that the UK grid not being able to cope with the demand being placed on it. Healthcare is one sector, manufacturing is another, ships are another one. So I don't know if you know a fact, one of the ferries that runs between the UK and France, they're now battery operated. They take 16 MVA of power to charge them. So that's one hospital just to power up one ship, okay? So the challenge will be is to use more and more of those distributed energy resources and almost see the grid as your backup supply.
Yeah.
You're doing your own generation locally, you've got a microgrid in place, you may have small-scale nuclear reactors, you may have a whole host of different mixes of energies, but you'll be almost self-sustainable in your own rights.
Yeah.
And then you'll rely less and less on the grid, because the grid hasn't got the capacity, hasn't got the infrastructure to do it. That's why the government's announced that huge investment recently in upgrading the grid.
Yeah, absolutely. And I guess that's going to also impact the way we do maintenance of our assets, because now we're running those assets as part of the normal business, rather than just running them for testing, which normally leads to empty fuel tanks, problems, errors, etc. So is that going to be part of the advantages, let's say, of using a microgrid and all the load management systems?
Absolutely, absolutely. I think being able to operate the network and visually see the network in real time is the biggest benefit, because this is the only way we're going to move forward, because within there you can see the actual power demand, the running of the network in real time. You are then able to look at your isolations, you're able to set all of your intelligent load shedding forecasts in the event of a failure. So within there, having a real-time simulation for the network is absolutely a must now.
Yeah,
moving forward.
Fantastic. Yeah. So going back to you, just last question, is you raised some few interesting topics about documentation and the value of having live documentation, let's say. So do you think, based on that electrification is better placed when we talk about greenfield projects? You see more electrification projects in greenfield or more?
So I think that both brownfield and greenfield need digital twinning and electrification. So in the first instance, I've been involved in many healthcare projects where they've been designed, they've not used the right tools during the design process. The first day they've come to switch them on, they don't work properly because they've been incorrectly designed. They've not done the modelling, they've not done the simulations. We see that all the time. So I think greenfield, brownfield, it doesn't really matter. Yeah. You have a defined process to follow, and that is you model the power system, you then understand all the operational scenarios, you do all the calculations before you buy any equipment. How can I specify a fault rating for a switchboard panel without knowing what the fault level is? And I can only calculate the fault level in a power system model.
Yeah.
So this is these are the misconceptions that are in the industry. People quote 80 kA fault rating for a low voltage switchgear. How do I know it's 80 kA? Is it really? Without doing the proper tools and modeling and do the simulations properly, that is the right way to do it, because you optimize the design, you ensure it's built in a model space that you can run all the simulations, as I say, before you spend a penny.
That's right. People will think that a greenfield is the easiest because it's a blank canvas, but unless you have those processes in place to start with, it's no different than a brownfield, because all you're doing then is playing catch up, and it's more cost.
In a utopian world, from a greenfield site, you build a power system model. When the hospital gets handed over, that model then gets transferred into the operational space. You then use that model to run all of the future predictions of load. You use that then to connect to assets in the network to get real-time data. As I say, that becomes a functional, really important part of a healthcare establishment.
It is the day-to-day running of that environment, without doubt.
Fantastic. Well, thank you very much, both. I hope these insights will motivate our viewers to start their electrification journeys. So this is the end of our section. We can see how electrification is not a challenge-free scope, but the technologies are there, the digital twins and the tools are there also. So definitely we can start our journeys and work with our customers. Next, let's head back to Briley to see what's next on the electrification of healthcare facilities.
Thank you, Dan, Derek, and Kevin, for lending your technical expertise to today's discussion. If I can distill a key point from all of the conversations we've had here today, it's this. The move towards the all-digital, all-electric hospital is no longer a distant aspiration, but an achievable reality with profound benefits. However, arriving at that reality requires careful planning, investment in new technologies, engineering expertise, education, and collaboration across all disciplines within the estate. An ecosystem of trusted partners is equally essential in your pursuit. With specialized expertise in the healthcare sector, a best-in-class portfolio of software, and infrastructure solutions for the all-electric hospital, Schneider Electric would be honored to be included in your network. To learn more about the rise of the all-electric hospital, please take advantage of the white paper referenced on your screen as well. As we approach the close of today's innovation talk, I'd like to extend my sincere thank you to all of our panelists for sharing their invaluable insights. I'd also like to thank you, our audience, for your active participation and engagement in today's session. I hope that you found today's innovation talk informative and inspiring, and that you'll consider joining us as we return to the series in 2025. Thank you for watching, and we'll see you soon.